Hello, today we're doing lesson 4.8. We're going to talk about the quadratic formula. This is another way to solve quadratic equations. The quadratic formula can be used to find solutions of quadratic equations. Let a, b, and c be real numbers such that a does not equal 0, and the solutions of the quadratic equation are as follows. We can solve x, and we can solve for x by plugging our a, b, and c into the quadratic formula. So we're just going to go ahead and start practicing this. The hardest part about this is simplifying at the end. So that's what I want to focus on. You've all seen the quadratic formula before. Okay, right now we need to get it in descending order, so we need to subtract 2 on both sides. So we get x squared plus 3x minus 2 equals 0. I like to label a, b, and c. A is 1, b is 3, and c is negative 2. Okay, go ahead, plug everything in. So I plug b in, I get negative 3 plus or minus. I just go ahead and do the b squared, so 3 squared is 9, minus 4 times 1 times negative 2, all over 2 times 1. Okay, so what I usually do is I'll simplify this first. So I'll go ahead and do negative 3 plus or minus 9, this ends up being 9 plus 8 because negative 4 times 1 times negative 2 is positive 8, so we get 17 over 2. Now, what you want to do is you want to check to see if you can reduce the square root. If you can, reduce it. The last thing you would want to make sure is see if you can divide anything out of this term, the term that's in front of the square root, and this term. We can't, so we're just going to go ahead, stop here, and this is our answer. Okay, let's go ahead and try the next problem. Again, we do not have this equation equal to 0, so we're going to subtract 12x on both sides, and we're also going to add 9 on both sides. When I do that, I get 25x squared minus 30x plus 9 equals 0. This is A, this is B, and this is C. So my B happens to be negative 30, but in the problem, B is already negative, so that becomes a positive 30. Plus or minus b squared, when we square 30, we get 900 minus 4 times 25 times 9, all over 2 times 25. Okay, go ahead, simplify this. When we do negative 4 times 25 times 9, we get negative 900. So 900 minus 900 is 0. So we end up with 30 plus or minus the square root of 0, which is 0, over 50. So this whole thing is gone. We end up with 30 over 50. We want to reduce that fraction, so my answer is 3/5. Notice we only get one answer in this problem, and that's okay. We're going to talk about our solutions after we're done doing these examples. Let's go ahead and try the next problem. Okay, again, I do not have this equation equal to 0, so I subtract 5 on both sides. I get negative x squared plus 4x minus 5 equals 0. This is my A, negative 1. This is my B, 4. And this is my C, negative 5. Go ahead and plug it into the formula. So I get negative 4 plus or minus B squared, which is 16, minus 4 times negative 1 times negative 5. So what I usually do, like I said, is I simplify the square root. So I get negative 4 times 1 times negative 5 is negative 20. So I end up with 16 minus 20, which is negative 4. So I get negative 4 plus or minus the square root of negative 4 over negative 2. When I simplify this, I get negative 4 plus or minus 2i, because the square root of 4 is 2. The negative, we pull that out as an I, over 2. Now, we only simplify at this point if we can simplify everything. So I can divide a 2 here, here, and here. So when I do that, I'm left with negative 2 plus or minus I. This is the part that we need to make sure we are practicing in class. Okay, go ahead, pause the video, try this, you try on your own, and then we'll go ahead and flip to the next page. Okay, now we're going to talk just about the solutions of the quadratic formula. So in the quadratic formula, the expression b squared minus 4ac, that's the part underneath the square root, is called the discriminant. You can use the discriminant to determine the number and type of solutions. So for example, when we actually have a positive number underneath the square root, we end up with 2 real solutions. Visually, what's happening is our parabola is intercepting the x-axis twice. So when this is greater than 0, 2 real solutions. It makes sense because if we go back to an original problem we had, Like number 1, we had -3 plus the square root of 17 divided by 2, and we had -3 minus the square root of 17 divided by 2. Now, if our discriminant equals 0, we only have one solution. So that would be when the parabola is just touching the x-axis and going back up. That would be like our example number 2. We got 3/5. We only got 3/5. And that's because we had 0 underneath our square root. So we're not adding or subtracting anything, so you don't get two different answers. Then when our discriminant is less than 0, we get two imaginary. That was like example number 3 when we got 2 plus or minus I. Those are imaginary solutions. That's when our parabola is not intercepting the x-axis, because those would have to be real numbers if they're on a graph. So we're just going to go ahead and practice the number and type of solutions by doing b squared minus 4ac. In order to do that, we need to make sure the equation equals 0. So here we're going to add 3x to both sides. We get 4x squared plus 6x plus 9 equals 0. So b squared, so 6 squared minus 4 times 9. When I do this math, I get -108. -108 is less than 0, so I want you to write 2 imaginary. This is what I want to see as your answer. This problem, we're going to subtract 5 from both sides, so we get 7x squared minus 2x minus 5 equals 0. So I plug b in, I get 4 minus 4 times 7 times -5. When I do this math here, I get 144. 144 is greater than 0, so I have two real solutions. I bet you can guess what this one's going to be. Subtract 6 from both sides. -5x squared. Notice I'm writing it in descending order. Plus 10x minus 5 equals 0. So I get 10 squared, so that's 100, minus 4 times -5 times -5 equals 0. So I get 0 equals 0, so that's one real solution. Pretty easy, right? Okay, go ahead, pause the video, try the try on your own. Okay, welcome back. I want to make sure that you have all of this information memorized, the quadratic formula, and what happens when we get solutions to the discriminant. Any questions, comments, or concerns, go ahead, write it on the bottom of the paper, and I'll see you tomorrow.